So it says use implicit differentiation, and the hint I gave you was that if y is equal to f inverse of x, what does that mean? X is equal to what? F of y. That's correct. If you now differentiate both sides, if differentiate both sides with respect to x, the left becomes dx over dx, and this becomes f prime of times what? dy dx. Because you have to use the what rule? The chain rule, right. What are we isolating here? What do we want to isolate? Well, first of all, what's dx over dx? So we have 1 is equal to f prime of y times dy dx. That's correct. What does y equal? Y equals f inverse of x, right? So what do we now know? 1 is equal to f prime of f inverse of x times what? Dy dx.
Divide by that.
Divide by that. So you get dy dx is equal to what?
1 over
F prime of
inverse
x. Correct. Is that exactly what we wanted?
Yes.
Are we sure?
No.
There's one last little piece here. What's the thing? We're trying to show that we just showed that dy dx. What is dy dx?
It means f prime of x. It's not.
So we have a little cleanup to do, right? We have a little cleanup to do. Is that correct?
Yeah.
One last little thing here. We end up with this is equal to that. So what do you end up with? F inverse of x, the derivative of that is equal to 1 over f prime of f inverse of x. So what does this say? If you want to take the derivative of the inverse out of value, what do? 1 over the inverse at that value into the derivative. Into the derivative. Yes, that's correct. So 4 pi r squared dr dt, right? But we want it when t equals 5, right? Dr dt when t equals 5 is equal to what?
2.
Is equal to 2. It tells us that, right? It equals 2.
So just
Plug in 2 where? Right there. So dv dt when t equals 2 is equal to what? 8 pi r squared times 2.
And we know what r is.
Oh, what is it?
5.
No, it tells us that the radius of the balloon is 30 when t equals 5, right?
Yeah.
And you could say, so I'll say this, so dv dt when t equals 2 is when r equals 30. I'm just doing this in my own notation, so what's that going to be? 8 pi times 900, yep. So what's it going to be? 7,200 pi. That seems like a relatively big number, but think about the balloon. It has a radius of 30, right? Every time you move it, every time the radius increases by a little, what happens to the volume? It goes up. It's a bunch of, the numerically large. Does it ask for the units? You sure? Indicate units of measure? What are the units? The radius of the balloon in feet. Okay, so this is volume, right? This is change in volume. So this is feet cubed per. Is it minute or second? T is in minutes, I think, right?
Yeah.
T is measured in minutes. So this is feet cubed per minute. It's also a minute. It's a long time. Okay. How'd we do? What do you think? Oh, look. Did we get it exactly right?
Yeah.
We did.
So is the proper way to do notation like dv dt line down?
You can do that. That's totally fine. You see how that line down there with the t equals 5? Yep. They don't write the r, but you could. It doesn't. The notation isn't that important as long as you note that like you're doing this when t equals 5, so therefore r equals 30, and they get the exact same thing we did. Good. Cool. Okay, let's keep moving. It says use a right Riemann sum. I hate it when it does that. Use a right Riemann sum with 5 subintervals indicated by the data in the table to approximate that right there. So what does this mean? It means the integral of r prime from
0 to 12.
0 to 12. So we're using right Riemann sum, right? With 5 subintervals. Do they nicely give us a table that works well?
Yep.
They sure do. You don't need to make a graph. You should just be able to do the math. So the first interval, oh, that's a picture, so I can't erase it. Where there's the first, the second, the third, the fourth, and the. What's the width of the first interval?
2
2.
times
2 times 4 plus. Nope.
3 times 2.
3 times 2 plus 2 times 1.2 plus 4 times 0.6 plus
1
times 0.5. That's the right endpoints because we use it to the right. This interval, so that one right there. This interval, so that one. This, so that. This, so that. This, so. This would be the right. Just for our own, what would be the left? 0 times
5.7
plus 2 times
4.0
plus
3 times 2
3 times 2 plus 7 times.
2.
Not
2
7.
times
I'm sorry. 2. I'm reading this backwards. 2 times what?
1.6
Plus
4 times
4 times 0.6. That's not what we needed, but that's the left one. If you wanted to do the left one, you don't need to make a graph. You can if you want to. This comes out to be.
What notation can we read that in? Because I mean,
You want to read what the question asks. It says, indicated by the to approximate. Using correct units, explain what it means in terms of the radius of the balloon.
well, okay.
It says explain what it means by the radius of the balloon. So you add it all up. So if you add the rate of change of the radius is, what units is that in? Feet per minute, right? R prime of t is equal to feet per minute. So we add this all up. I'll just get it. Oh wait, sorry. So we can look at this. There's like an extra carriage return that it's doing. I don't know why it does that, but it does. Did we get the same exact thing?
Yeah.
Yeah, there it is right there. So what is it? It's the change in radius in feet from 0 to 12 minutes. It's the change in radius. Each one of these things represents an amount of change in radius.
And I'm assuming they want an exact answer like 19.3.
Yes,
Okay.
to 3 decimal places. Always 3. And if it's zeros, you can drop it. Does that make sense, everybody? So it's 13. You could put 0, 0. That's fine. But this is important. Change in radius from 0 to 12.
Okay. Wait. Would it be? Okay. I mean.
When you add those fractions up, they come out to be
No,
exactly
that's-
19.3.
That is
Oh.
not what I'm referring to.
Yes.
Okay. Riemann, like with the integral of that, is it? I know it's change in radius, but is it the total change in radius, like the composite change in radius
Yeah.
completely?
Is the change in radius from 0 to 12 minutes.
Okay.
So it has grown by 19.3 feet. From time equals 0 to time equals 12, the radius grows by 19.3 feet. You could say that instead. Totally fine.
Isn't that just an approximate?
So totally wrong. Mr. Seamon was totally wrong here. The function is always infinite, but that's not what we're integrating, right? We are integrating what? No, we're integrating
Derivative.
r prime of t, which is what?
Decrease.
Decreasing. How do we know it's decreasing?
Because it's, well, one, the value's in the table.
But how do, yeah, okay, so it tells us that, but how do you, it says r, what does it say?
Concave down the entire time.
It says r is concave down. R concave down
Therefore,
means what?
R prime is decreasing.
Not all the time.
Are you sure? No, ready?
No.
R concave down, it's increasing like this, right? It's concave down, but R is increasing, right?
That's a
What they want you to, R
No.
prime,
R prime is the slope.
R prime on that would be decreasing.
so therefore r prime of t is decreasing. R prime of t is decreasing. So therefore, with right endpoints, the estimate is what? Is below. You're right. So what was my mistake there? Why did I get that one wrong?
You were going off of R instead of R prime.
R prime. Going off of R instead of R prime. Good catch. That was great. Good job. When you see something that you should be like, yeah. How many points do you think this is worth? I think it's worth 2. 1 for the derivative. I mean, it can't be worth 1 because they don't give fractional points. So I think it has to be worth 2. So if we do this derivative, you get f prime of x is equal to 1/2 k to the 1/2 k of x to the negative 1/2 minus what?
X to the 1, or 1 over X.
Yeah, minus 1 over, or x to the negative 1. That's totally fine.
Okay,
Easier
so that's
to do the derivative.
Yeah.
Totally fine. What about f double prime? F double prime of x is going to be what? 1/4 kx to the plus x to the. Okay, good. Do we have to add constants on this? Because we're taking derivatives, not integrating. Don't mix those two things. I don't even know why I brought that up. For what values of k does f have a critical point at x equals 1? Critical points are where the function is what or what?
Or does not exist.
Where the derivative, first derivative, does not exist or equals what? So we want 1/2 kx to the negative 1/2 minus x to the negative 1 to equal what?
0.
To equal 0. So that's going to be k over 2 times the square root of x minus 1 over x is equal to 0. Did I write that right?
Yeah.
Is that correct? Yeah. So what do we have here? K over 2 root x is equal to 1 over x. Is that correct? So kx is equal to 2 root x.
Yeah.
So k over 2 is equal to what? Root x over, what's root x over x? X to the what?
X to the negative 1/2.
Negative 1/2, right? So what's k equal to? 2x to the negative half. Is that correct? It says,
When X is equal
when x is equal to 1. Oh, did I miss something here?
Yeah.
1. Yep.
So we want this derivative. Oh, so do we have to do any of that hard stuff? No, this was total overkill. Oh man, I'm so excited about this problem. This is overkill, right? This right here, you want equal 0 when what? When x is equal to
1.
1. When x is equal to 1, you end up with 1/2 k minus
1.
equals.
0.
So we get 1/2 k is equal to 1, so k is equal to 2. Another way to look at this now is now plug in 1. What do you get? 2 times 1 is 2. So is that overkill? Yeah. Would you get the same answer?
Yeah.
Sure, and it was like 2 seconds if you did your algebra correct, but you want to minimize how many chances you have to do this. Because if you do that 10 times, 1 out of 10 times you're probably going to do something wrong. Okay, so we got k equals 2. Does it ask us for anything else? Ooh, for this value of k, determine whether f has a relative minimum, relative maximum, or neither at x equals 1. How do you do that?
First derivative.
No! No, you can, but what did they set you up with on part A? They gave you already figured out the second derivative, right? You already did the second derivative. So if x is equal to 1, what is the second derivative? So f double prime at 1, when x is 1, right,
Yeah.
is going to be what? Negative 1/4 k.
Because now we have a value of K.
Well, hold on. I'm not putting in k yet. I'm going to put it in. Negative 1/4 k plus what?
Are we
Plus
supposed
1.
to make K2?
Look, for this value of k, so yes, we will. But look, once we plug, we'll do one thing at a time here. So what is f double prime at 1 when k is equal to 2? What's that equal to? Negative 1/2 plus 1. And we want to know if that's what or what?
Positive. Right?
Positive or negative. That is what?
Positive.
That's greater than 0, right? So therefore the graph is, if the second derivative is positive, it's going to be
Concave up.
concave up when x equals 1 and k equals. So what happens there? And does it ask you for absolute? What does it ask you for? Relative? It's a relative what? Relative minimum.
Does relative mean local?
Yes.
That's
Yes.
For that point.
Yes. For that one. Yes. For that one right there. So let's just check our answers here for a sec. I think we're doing okay. Let's see here. We good? Yay! Did we just get 6 points?
Yep.
We just got 6 points. And was that a relatively easy 6 points? Yeah. When you get to part B, sometimes and frequently, what are you going to have to use? Part
Hey.
A, yeah. So let's look at part C here. What does it say here? It says, now it gets more fun. For a certain value of a constant k, the graph of f has an inflection point on the x-axis. Inflection point. What is an inflection point?
Where
Where the concavity changes. Thank you. Where the concavity changes. Second derivative being 0 is a requirement, but it's not. It's necessary, but it's not what? Sufficient for it to be.
Say value of A or K.
K. It says a value of k, right? You can't have that a there. So this is pretty clean, but we're not quite there yet. What do we know? We know that this is true, right? So we want that. We need to look where that crosses the what?
X-axis.
So where does k root x minus ln x equal 0? Well, that's where k root x is equal to ln x. So that's when k is equal to what?
ln x over x.
Over what?
Root x.
So that right there is the 1x intercept, right? So that means that that's equal to what? Yes. So what do we do with that a value?
Put that in for.
Put that in.
over-
Do we put that in there?
Yes.
It has to equal 0, right? So let's set this thing equal to. We'll set that thing equal to 0 and solve for what? What do we solve for? We solve for what? K? Okay. So if we do that, so end up with K.
We'll just get the same thing.
Oh, wait. Do we get the same thing?
Yeah.
Oh, look. We get the same. That's exactly what we just did, right? So, okay, so this tells us from above, we did the work already, that K is equal to what? 4 over what?
I guess that's helpful because it keeps it all in the same area.
K is also equal to L and x.
Ah, so you also know that's where the second derivative needs to be 0, right? But we also know that that has to be where
The first derivative, or first.
Where the function-
is equal to 0.
where the function is equal to 0. Does that make sense, everybody? Where the function is equal to 0? So what did we have there? K root x minus what? Is it k root x minus ln x? Right? I think it is. We want that to equal what? Because we need it to actually touch there, right?
So we find
And that happens when k is equal to over what? Root x. So we do this because the function itself, the function f of x, crosses the x-axis, right? And this is where the second derivative equals 0. We need the second derivative to equal 0
And the function.
and the function to be there because what are we trying to do? We want there to be an inflection point on the
So you
x-axis.
set ln x over
4 over root x is equal to ln x over root x. So you end up with,
4 equals all of them.
4 root x, ln root x.
well, this 4 equals ln x. So x is equal to,
Even 4.
but we want the k value, right? It's asking for the k value. So it's k is equal to 4 over the square root of. So it's 4 over. This is a hard question. This is not easy.
How many points?
I think it's 3. No, it's not. Record. At the point 1, 1, what's the dy dx? 1 plus 1 over 1 is 2. What about at the point 1, 0? Remember, x is 1, y is 0. That's 1 plus 0 over 1, which is 1. What about at 1, negative 1? That's going to be 1 minus 1 over 1 is
0.
0. Okay, so we just did 3 of them. You're not done yet, though. What does the slope of 0 mean?
It's a line.
Use your arm. What is it? So what do? You draw a little tiny little segment right there.
So just do a little second.
A little tiny segment, because it's only at that specific instant, right?
Hey.
This is a current in the ocean. In the ocean, currents are going different places everywhere, but each individual point has a different speed and direction. So what about at this point right there? What was the slope? 1. So you do a slope of 1. What about at 1, 1? It's a slope of 2. So you have to do those other points. So what about at the point 2, 0? 1 plus 0 over 2 is 1/2. So that's 1/2, so it's a little less steep like that, right? What about the other side here? So let's do the points. Let's just do all of them. And dy dx. What about the point negative 1, 1? 1 plus 1 over negative 2. So that's going to be, that's a bad negative 2, so how about like
I take it
that?
this will be reflected in-
Not always. Not always. This one
In
is.
this one, in the case
Yes.
that they're all nice.
Yes, they're all nice. When they make you graph these, they're not going to be like, please graph the slope of 1.625. No, no. So what about negative 1, 0? What's that going to be? 1 plus 0 over is, so it's,
I'm assuming if
Negative
you take
1.
the booklet, you have it.
you have a lot of
graph
space.
paper too.
Well, no, actually you don't. You're just estimating. This is just an estimation question. So what's this one? 1 minus 1 over negative 1 is 0. So that one is like that. And we have one last point. What is it? Negative 1/2. Yep. 0 is going to be 1 plus 0 over negative 2 is. Are all of these going to be symmetric like this? No. But that right there is just basic math. And when they grade this, everybody, they're going to look for, is each one positive or negative, and is it relatively close to what it should be, right? So this is supposed to be 0. And if you make a table like this, this is really helpful. It helps
It shows that you
literally.
do the math and that you.
The thing that people skip and they mess it up, they go straight from this to this. And do they mess it up?
Yeah.
Yeah, because they'll like maybe switch the x and the y one time. Literally, this takes half a second to write. This column, do it. Write that middle column. Okay, so there's the slope field. What this represents is all of the potential integrals. Because to get an integral, remember you need an initial condition to isolate it. If you're in the ocean's swirling around, right? If I put a boat in one point and I put a point in another point, are they guaranteed to end up in the same place?
No.
No. Where they start dictates where they're going to
End.
go or end. Right, exactly. So in this case, this represents a way of showing all of those functions. If we zoomed out, could you make this to finer detail? Could I graph the little slopes at each little point? Like, could I divide this up into 10,000 things?
Yeah.
Would I get this cool current thing? Absolutely.
And I'm
And
assuming
if you
people
put a
have done
point
that.
on there, can you tell where each point is going? Yeah. If I started here, where's the point going? This way. And then once you get to the next point, what do?
Sure.
Calculate the next one
Where
and
it's
the
going,
next
so
one.
it starts doing
But you
something
need
different.
an initial condition. So what does part B ask right here? Find a particular solution y equals f of x, and look what do they give you? What do they give you? Initial condition. They give you an initial condition. So the first thing you need to do is you're finding y equals f of x. They start with a differential, but you're trying to get y equals f of x. So what do you know you're going to have to do at some point?
Isolate.
Why? What's our overall goal? We're trying to do what to this? We're trying to...
Find a solution.
Are we trying to integrate again?
You're trying
Are we trying to differentiate again?
Yeah.
No, we're trying to...
integrate.
We have a differential. We want the
Integrate.
function. To go from the differential to the function, we need to integrate. But to integrate this, we need to separate the variables. dx need to get attached to
Yeah.
x, and dy needs to get attached to y. So if you cross multiply this, you don't quite have what you need.
No.
You end up with x dy is equal to 1 plus y. Is that what we want? No, what you want is 1 over 1 plus y dy equals 1 over x dx. Is that separated?
Yeah.
If you don't do that, you get no points on this question. This is a huge thing here. This is probably worth at least 5 or 6 points, and if you don't separate, they don't give you any points on
Is
this.
that the way you should set it
Yes.
up? And should, okay,
Yes.
So
So now you integrate this. You integrate both sides. What's the integral of 1 over y? No, not 1/2. ln of 1 plus y plus c equals ln of
X plus C.
plus d, right? And can we combine our constants? Do you remember this, everybody? So what do you end up with? ln 1 plus y is equal to ln of x plus e. What are we trying to isolate? Y. It's telling us to find y equals f of x. So what do we need to find?
The ln of
Y. We need to find y. So this is in what form is this in? Logarithmic. We need to turn it into. So this is going to be e to the ln x plus capital E. That's a bad choice. Equals 1 plus y. So that's e to the e. E to the ln x is equal to 1 plus y. Can we just call this f? We're okay with that? What's e to the ln x? Anybody remember?
Oh, is it dumb?
Does anybody remember what e to the ln x is? E to the ln x is equal to something. Do you agree?
Yes, because it's
You agree to that, right?
something with e. Yeah.
Okay, let's take the natural log of both sides. ln x, ln of e to the is equal to ln of question mark, correct? I just took the natural log of both sides. What can I do with the exponent? Ln x, ln e is equal to ln of question mark. What's ln e? So we have ln x is equal to ln question mark. What does x equal? Question mark. So this equals x. Guys, a to the log base a of b is always equal to b. So what is e to the ln x equal to? X. So you have f times equals what? So what does y equal? These are terrible letters for me to choose. We're not done yet because that f is still there, right? That's a constant. How do we solve for that constant?
So give you the value.
They give us what? They give us an initial condition. F of negative 1 is?
1.
We know that f of negative 1 is 1. So what do we know? 1 is equal to f times.
1.
So 2 is equal to negative f. So what does f equal? So what is our question? What y is equal to what?
Negative 2x minus 1.
Negative 2x minus 1. We're not quite done yet, I don't think. I think it asks a little something else. Let's see. It says, oh, and state its domain. What's its domain? Domain is all real numbers. So what does that mean, everybody? That means, in terms of this graph, let's go back up and look. What was the point? Negative 1, 1, right? F of negative 1 was 1. So we're looking at what point?
I have a question.
Listen, f of negative 1 is what? Hold on, I'm going to pause this for a sec. The question really is, when you integrate this, when you do this, is it ln? It is ln, but what is it really? Like this, right?
Those values.
Of these values, like this.
And you have to keep those absolute values all the way to the end.
And what does it come out to be? Let's just go out to here. Hold on. You should be able to fly through this one. What do you get? 1/2 y squared is equal to negative x squared plus what? K. Is that correct?
Yeah.
Because I like it.
Excellent. And do you have to isolate y here? We don't have to. What do we really want to solve for?
Okay.
K. We
So
know
we
that
just
f
want
of
you-
1 is negative 1, right? So 1/2 of negative 1 squared is equal to negative plus k. So what do we end up here? 1/2 is equal to negative 1 plus k. So what's k equal? 1/2. So what do you get for an equation? 1/2 y squared is equal to negative x squared plus. What does this ask you for, though? It says find the particular solution y equals f of x. So what do we need to solve for?
Isolate y.
So y squared is equal to negative 2x plus 2x squared plus 1. So y is equal to plus or minus the square root of negative 2x squared plus 1. That is two of them. You need to choose one of them. How do you choose which one?
The domain of the
Well, what does it tell you? It says f of 1 is equal to
negative 1.
f of 1 is equal to negative 1. When you plug in 1,
So it says minus.
f of 1 is negative 1. So what does it need to be? F of 1 is negative 1, so you need the output to be negative. What's the only way to make the output negative?
Negative.
To put the negative on the outside.
Outside.
Can the square root itself ever be negative?
No.
The principal root of a square root is always positive. So what do you get? Y is equal to negative the square root of squared,
Negative 2.
negative 2x squared plus 1. There it is. Was this a really nice one?
Yeah.
Absolutely. How many points do we think this is worth? Yeah, did we get something wrong, Tony? Simple mistake killed us right there. You go back and check it. Look at it. Basically, you should read the question. What is this question asking? Say that out loud in your head.
Say that out loud in your head.
Yeah, just no, literally. Okay, it is asking that. And hey, that didn't work because he couldn't evaluate.